coming. Thank you for giving me the opportunity to share some of these ideas and thoughts and think together with me to our presentation today. Uh, there is a lot of material, a lot of scientific information, and I believe the presentation will be available later on. And we don't need to focus on the dates and the specific science and information that's in here, but the message about our history, where we come from, why we're here, where we're going. This is a story that we're trying to synthesize today. And we're going to cover the universe, our solar system. We're going to cover our planet Earth, such a special place, highly engineered in every tiny detail for us to be here. Life on our planet, and finally, our evolution until the birth of free will that brought us here today. There's this extensive bibliography, and it's available for everyone. But first, I want to invite you to do something different tonight. Usually, in the history of science, we use our so-called scientific method that keeps science at the base it has brought us today. Scientific investigation, methodological investigation, so we can explore all single aspects of the problem that we're trying to solve. And for that, we use math, then physics, then chemistry, astronomy, and each one of those lines of science is built upon the other, in math, the very first one. And then with math, we can use physics, and with math and physics, we can get to chemistry and so forth. And also, we've done extensive investigation in our planet. So we have paleontology, we found fossils, we tried to build the story of our planet and life on our planet through those fossils. We have archaeology and anthropology. Anthropology is the story that's not told, it's not written. So we read our own story through anthropology and through archaeology until we get the story, which starts when we start writing about ourselves and leaving official registers about our life, about our view of the world in our time. And the scientific method and our technology are the tools that allow us to build our development as human beings today. And usually scientists and people throughout history, they count on their intuition to start understanding a problem, and then they counted on all the scientific tools and the scientific methods to explore the problem. I want to invite you today to do something different and work in the other way around. We are going to try to use our intuition not to start the scientific investigation, but to expand. Because we are fundamentally operating, studying under the Spiritist doctrine. And the Spiritist doctrine brings to us the ability to try to understand the world around us, understand ourselves through our intuition and through the communication, the best communication we have with spirits, and opening our mind to understand not only through scientific methodologies and technologies and instruments that can measure events and things that are happening, but also about what we think about them based on everything that we learn from the doctrine, from the laws of the God's laws, the laws of the universe. And that's the invitation I want to make to you today. Let's build upon all the science that we learned up until now, and then use our intuition and use our heart to try to understand what we cannot measure today. So let's begin. 14 billion years ago, time, energy, and space were all confined together in one tiny little spot that not even had dimensions. We couldn't measure it. It's called the original singularity. Everything was condensed. And we say energy, time, and space, we don't usually mention matter because matter is an organization of energy. Today, through physics, we know that energy vibrates in several different spectrums. You have the muscle-tile ones, they're very pure, very highly elevated, and you have the most dense levels of energy that turns into quarks, turns into elemental particles, that turns into subatomic particles, that then turns into electrons, neutrons, protons, that turns into atoms, that turns into molecules, that turns into the elements that compound the entire universe, including ourselves. So this is the story we're going to tell today. About 300,000 years after the Big Bang, those elements started to form. And we know this through physics. And about 4.6 billion years ago, our planet was formed. And we know that thanks to geology. And 3.6 billion years ago, certain molecules that were floating in the primitive ocean, they started to behave differently. And they created what we call life today. And then about 6 million years ago, one very specific type of mammal started to live in the world, in the earth. It was the first primate. And about 4 million years ago, the first primate stands up and starts walking on 2 feet. And 2.5 million years ago, the very first genus Homo appears on Earth. This is not an ape anymore. This is somebody that is very related to us, including from a DNA perspective. And 70,000 years ago, a very special type of Homo neanderthalensis, started to expand from Africa into Europe and started to conquer nature and to build tools, to create things to make his life easier. And he started to create the first steps of a community life that expanded beyond the band, beyond the family band into a primitive tribe. But then 40,000 years ago, a different species of Homo appears on Earth. It's the first appearance of Homo sapiens. And the brain of the Homo sapiens is so different that allows it to think abstractly. And this allows the Homo sapiens to create something called culture. And that's where everything else happens. And about 12,000 years ago, we stopped rambling around, extracting things from nature, hunting whatever was there, and we started to dominate the environment. We started to take advantage of the knowledge that we gain about the seasons and how the nature behaves. And instead of collecting, we started to use the land and the animals in our favor to make our life better. And approximately 5,000 years ago, the first civilization appears on the planet. And 2,000 years ago, Jesus Christ incarnates among us. And about 500 years ago, the scientific revolution starts. If we could look at the planet Earth, entire history of planet Earth, and make it fit into 24 hours, let's say the planet is formed at 0 hour, 0 minute, 0 second. Everything happens in our evolution, and the modern man, modern humans, they appear on Earth at 11 p.m., 59 seconds and 59 minutes and 56 seconds. The Earth is here for a long time, and we've been here only for 4 seconds. Imagine all the engineering, everything that happened in the planet to prepare the planet to take us where we are today. How special is this place? And what is our responsibility to keep it for the next generations? Because we are a spark in the story of the planet, in the story of the universe. Our own existence as a human group. But like I said, it all started here, the primordial singularity. And all energy was here. All time and space was also here, condensed in a point. Nothing else existed outside the singularity. And then, one day, it all exploded. We call it explosion because we can hear the remains of the sound of the Big Bang through very powerful telescopes that use radiation to screen the universe after the sound of the Big Bang. And we detected it. But was it explosion? We don't really know. What we do know through our science and our intellectual and imagination working with our tools is that exactly 10 to the power of minus 32 seconds after the Big Bang, the cosmic inflation ends. You always think about an explosion like a grenade or a bomb or something. It's all that energy contained in one single spot and then explodes and throws pieces all over in a sphere environment, all over the different places. So the inflation of the singular, the priority, the primordial singularity took 0.31 zeros and 1 second to expand to the size of our current universe. And 10 to the power of minus 6 seconds, protons were formed. And then about 100 seconds later, the first elements started to show up. So energy expands, vibrates in several different spectrums. And the lower spectrums, they condense into quarks, condense into particles that turn into subatomic particles, the pieces of our atoms, and then elements. It all took 100 seconds. 100 million years later, the first stars formed. So in the primitive space took over very, very fast. And then time started to happen as matter starts to travel from place to place into the universe. And as we know, there's no time if there's no movement. Time depends upon particles moving. And the particles were rearranging itself until they start to collapse into each other, forming larger rocks, large amounts of large objects with several different types of elements in there, until they hit through the speed and they became the stars. And 500 million years after the Big Bang is the record for the star creations. Billions and billions and billions of stars and solar systems and galaxies were already formed and populating the universe. And 4 billion years after, there's the peak of star formations. So the universe as we know today, it all happens in 4 billion years. But all the elements and the organization between matter, time, and space happened very fast. And since then, we are organizing all those things to create the matter, organize the matter, create large corpses that are floating in the universe so they could become stars and planets and everything that we see around us. And this is the Big Bang story. And that's how we got to our modern universe. And this is what our scientific method tells us. And every time we think about the singularity and we think about God, usually this is what we think. God acting upon the singularity and making everything happen afterwards. Here I want to make a second invitation to you. Let's not think about God as an external element to the singularity. And we have evidences of that in Paul and in Kardec itself.
There are several passages, especially written by Paul, that puts God as the main element inside the singularity, inside the origin of the creation. So if God is part of the singularity, if God is the highest level of energy in that mass of energy, time, and space, and God commands itself to explode into the Big Bang and create the universe, and through that action, God creates every single particle, subatomic particle, every single atom, every single element that exists in the world. Who are we? When we look to our side, we see ourselves in here. How old are the atoms that are compound in your body? When were those atoms created? We saw here, every single element that exists in the universe today were created around 100 seconds after the Big Bang, and they're still here. Recycling and recycling and recycling through several different processes in the universe until they become us. And God is not outside of the process. God is the process itself. So when we look at each other, when we think about love your neighbor as yourself, who are we loving? This is our Jewish, Christian, Western culture. If we go to the other side of the planet and we think about the Eastern culture, they say namaste. The God in me salutes the God in you. Because we're all connected to the Big Bang, to this primordial singularity here. And we are connected to God. God didn't make us. God created us upon himself. And that's the story that Paul, Kardec, and several other authors tell us. And we can relate that today to our science, to our knowledge. We have the evidence. And if we think about all the science information and then use our intuition to expand upon that, we can get to those conclusions. But let's keep moving. After the universe was created, we have matter traveling all over the place. And matter has magnetic energy. So particles, they were attracting each other and collapsing into each other and creating clouds of particles and mass in different portions of the universe. And the universe moves. The galaxies move through magnetic energy. And because of this movement, our solar system started to form like a cloud of elements dispersed in the universe and attracted to each other and collapsing into each other until we form a star. And because of all these elements collapsing into each other, falling into each other with speed and a lot of power, it creates the heat. And a lot of those particles were gases. And gas today is the element that combusts the sun. And then the sun had a lot of gravity as well, and started to attract a lot of other particles around. And we can see here the sun in the middle, and rings of other particles being organized through the magnetism of the sun around the sun itself. And that's the process that our solar system was created. Those rings, they had so much particles, asteroids, they were collapsing one into the other and creating larger and larger and larger objects. And those objects became what we call protoplanets. They are not planets yet, but they will be planets as they start receiving more and more and more material that is floating on the same ring. And there are several rings around the sun. And there's still rings of particles around the sun today. And we are very, very interested in two of those protoplanets. One of them is called Gaia, and the other one is called Theia. Gaia and Theia were the result of agglutination of material in one very specific ring around the sun. And they were on the same orbit. They were very close to each other, and they were orbiting on the same area of the solar system. Until one day, they collapse, one into the other. And this event that appears to be occasional, appears to be an accident, was so meticulously organized and engineered to create planet Earth that because of this collision, several things happened that were going to allow life to explode in the planet. If it hadn't happened this way, we wouldn't be here. What are those evidences? Well, first, this is, of course, the primitive planet. But the first thing that happened, the collision of Theia and Gaia pushed the new planet to the only area around the sun where water can exist in three different states. In the gas state, vapor, in the liquid state, and in the ice state. Closer to the sun, you don't have liquid water. Further from the sun, you don't have liquid water. You have ice in all those planets here. And water is the basic, fundamental place where life is going to be originated. But the collision of Gaia and Theia not only put our planet on the right place, but did something very, very important. All the planets, they orbitate the sun on the same plane. It's kind of like an equator of the universe. All the planets are aligned around the sun. And the planets are circulating the sun in its orbits, but they are also circulating itself, its own axis. And usually in the universe, we see planets with different inclinations of axis. But because of the collision, our axis was inclined in exactly 23.43 degrees. And why is this so important? Not only we are on the right place in the solar system that we can have water in the three states, but also because of this inclination, when we are circulating one side of the planet, our south pole is closer and our north pole is further from the sun. But when the planet is on the other side, now the north pole is closer to the sun and the south pole is further from the sun. So thanks to this, we have our very well organized 4 seasons on the planet. And again, life would not exist if our axis was perpendicular to the equator of the solar system, because we would have ice covering all the way up to the tropics on the north portion and on the south portion. And the water would not circulate all around the continents and would not allow life to grow in the planet as it did. So this is the second important effect of the collision between Gaia and Theia. And the third one, among several others, one special fragment of the collision escaped from the new planet, but was captured in the electromagnetic field of the planet and became our moon. And our moon keeps our planet spinning exactly 24 hours around our own axis. Because of the moon, now we have 24-hour days. If it wasn't for the moon, we would have much longer days, 36, 38, 40 hours. There are several different calculations. Scientists, they diverge a little bit. But everybody agrees that we only have 24-hour days thanks to the moon. And all of that happened in one single event. The collision of those two protoplanets that happened exactly at the correct time that was supposed to happen, and pushed the planet to the right place, inclined the axis of the planet so we could have the 4 seasons, so we could have water here, we and placed the moon to help us to have 24 hours a day. This is a highly engineered process. This was not happening by sorry?
By accident.
By accident. This wasn't by accident. But our planet was still far away from being ready for us to live on. The initial planet was bombarded for more than 1 billion years from extraterrestrial material that kept falling and falling and falling on our planet. And our planet was also hot. Very, very hot. And still is very, very hot today. We're going to see this in the next slides. But the extraterrestrial activity started to slow down as we attracted most of the particles that were around in our specific ring, and we cleaned the environment around our planet through that process. We still have a lot of material orbitating close to us, but it's much less than it used to be in the past, so now we can live here. Occasionally we have a meteor coming falling here and there, but not like it happened in the past. But also, our planet was alive. We had the magma circulating inside the planet, rock that is melted, very, very hot, circulating inside the planet and surfacing through hundreds, thousands of volcanoes. And this process brought a lot of the material from the interior of the planet to the surface. Here in the interior of the planet, they were submitted to a lot of pressure and high temperature. And here in the surface, they were released from all of that. From temperature, the surface is much cooler than the center of the planet, and pressure. There's no material on top of it. And through this process, a lot of gases were released into our atmosphere and were combined. And thanks to the extreme geological activities, we started to form water in the planet. So for other billion years, we just created water and accumulated water in our planet. And then the amount of water circulating in the planet started to create other types of phenomena, the meteorological phenomena. We had storms that last for 10, 15, 20, 100 years because of the amount of activity that was happening in the surface of the planet. The heat that was coming from the sun, because our atmosphere wasn't 100% formed yet, so the very little types of sun radiation would come to the surface of the planet and heat it up very fast. So water would evaporate very fast, and then would precipitate very fast. So extreme weather events, organizing, cleaning, washing the shores, washing the mountains that originated in the volcanic activities, and starting to create the sand, taking crystals of other materials dispersed in the rocks, and washing those materials into the ocean, and turning the ocean into the salty ocean like we have today, until it came down. So all those processes through time, they were calming and calming and calming until we reach the planet Earth as we know it today. And we think we live in a rock, a solid rock floating in the space. And that is a big misconception. Our planet is fluid, from the nucleus all the way up to this very last layer here, up here. If we cut an orange in half, and you look at the orange, you see the tiny little bark around the orange. That's exactly the same dimension of our solid surface. This is rock. And because this is circulating, all the heavy elements like metal, iron, is concentrated in the nucleus and is extremely hot as the sun. And other lighter material, because of the movement of the planet and the movement that happens in the magma, is accumulated closer to the surface of the planet. And here, the planet outside is cold. So the magma solidifies into rock. And we live on tiny plates of rocks floating on a planet that's liquid, a compound of magma. And those plates, they are what we call tectonic plates. And they move. And when they move, we have an earthquake. They are moving constantly, one on top of the other. And one pushes the other, one goes down and the other goes up, and that's what provokes earthquakes. And around those plates, where they have the boundaries between one or two or three plates, there's what we call the circle of fire. And all the volcanoes that are still active in the world today, they are located around the circle of fires. That's where the big tectonic plates that are pieces of solidified rock touch each other. And the magma surfaces there because there's a crack between those two tectonic plates. And that's where we are today. But again, it wasn't like that. We used to have only one continent, a big continent called Pangaea. And because the magma circulates inside the planet, it forces those tectonic plates to crack and to move. And this movement, through millions of years, created our continents as we know them today. And it's not going to be like this forever, because the center of the planet is not going to solidify. And our tectonic plates keep moving. And we also think about the big one that's been expected here, San Andreas Fault. San Andreas Fault is the encounter of two very large tectonic plates, the American continental plate and the Pacific Ocean plate. And this is happening all over the world. And other things kept happening. This is a big crate of the largest meteor to reach planet Earth in early times. And it is there. And this brought the extinction to dinosaurs, and 90% of the living organisms that were living on the planet when the meteor hit the ground. But what's important here is that all this process was highly engineered by God, by Jesus Christ, by the spirits that helped Jesus Christ to create this planet, to create life, to engineer DNA, to engineer all the living things, thanks to this, the precision orbit position of our solar system. The electromagnetic field that covers our planet, that is a filter that avoids the lethal radiations that come out of the sun every single second to get to our surface and to kill us. It filtrates and pushes away all the lethal radiations. Ice, water, and clouds, allowing water to circulate in the planet and create the very initial environment for life to appear. Oxygen, that was also created in our atmosphere during the highly geological period of planet Earth, when we had volcanoes all over, expelling material, solidifying, expelling it again, and separating all the elements, especially the gases. Monoxide, dioxide, carbon, that has a very, very important function, which is to regulate the temperature in the surface of our planet. And ozone, that also helps to filtrate specific radiations and keep the balance of our temperature in the planet. All of this didn't happen by accident. But let's take a look at the story once again. Let's take a look at this timeline. 13 billion years ago, the Big Bang happens. About 10 billion years ago, most of the galaxies are formed. And then 4.5 billion years ago, our solar system, and right after that, our planet Earth is born. And between 3.5, 3.6, 3.8 billion years in the past, life appears on the planet. And 220 million years ago, the dinosaurs were extinct. And then we came. So we measure time here in what we call geologic time, in billion years. And again, how old are the atoms that form your body? They are 13 billion years old. They were born here on the first very seconds of the universe. Not about the time life of life. It's also so extended that we still need geologic time to measure it. So the Earth is born here 4.56 billion years ago. And then around 4 billion years 3.8 billion years, certain particles that were floating in the ocean, they were subjected to thunders and rays coming from the atmosphere, and a lot of other elements of energy changing those molecules into what we call today amino acids. And we're going to see this today. And this is when life began. And then the first life forms helped to shape the atmosphere the way it is today. They synthesized oxygen and they helped to balance all the different gases that we have in our planet today, forming our atmosphere. And then the first cells with nucleus. Up until here, they were not cells. They were amino acids reproducing itself, turning into pure DNA floating in the ocean. And then the plants, and then the animals, and then us. Again, a lot of things had to happen to create the planet, to create the conditions we needed to put life into the planet. But even when we started to create life, we had to test life, test different forms of amino acids, test different forms of biological organisms here, tests different types of cells, different types of organs inside the cells to synthesize energy so the organism could live. And this is a huge laboratory where all of our DNA was tested and tested and tested through mutation, which is when a DNA changes, and a lot of reasons why DNA change. Most of them are non-natural, some of them are natural. Natural, I mean, in terms of being caused by the own DNA. Most of those causes are external. It might be radiation, it might be heat, it might be a combination of different elements, but the DNA changes to adapt, to live better, to live longer, to synthesize energy better, to reproduce better. And that's the huge laboratory that experimented for billions of years, again, for us to appear later on, very later on. So we are the top of billions and billions and billions of years of engineering, experimentation, testing, and creation. That's creation happening. And how do we know all of this? Well, we knew that in our primitive ocean, there are a lot of elements, chemical elements floating here, and they were subjected to a lot of different elements and radiation because the atmosphere wasn't there, so we had some little radiation coming from the sun, we had some other cosmic radiations reaching the planet, we had cosmic elements. So we say that the origins of life, they are terrestrial and extraterrestrial. Because some of these initial elements here, called amino acids, may have come from other asteroids. This is very possible. But the fact is, this is what really happened. Those chemical elements, especially the ones based on carbon, they started to organize itself into very, very specific molecules. And what differs these molecules from the other chemical molecules that we know? They can reproduce itself. There is one small amino acid here. If there's another amino acid here that have certain characteristics, they can connect to each other. And now they're a much larger molecule. And then there's another one there, they can connect, so they create huge chains of amino acids floating in the ocean. And the scientists, they calculate that we had huge molecules, kilometers and kilometers of molecules floating in the ocean. And those amino acids, eventually, they turn into DNA, pure DNA. DNA is a kind of very special kind of amino acid. And then in order for this amino acid, for this DNA to reproduce itself, it had to create a membrane around to separate it from the rest of the environment. But in order to live, he had to create several different organs inside the membrane. So he could take energy outside, other gases outside to synthesize the energy, and then he could put all the waste from the process outside. So created the first cells and the first unicellular organisms were living in the planet. and they're breathing, and they are helping to form and shape the atmosphere. And then they started to evolve through mutation, recreation, and they started to grow, and we had plants, and then we had all different types of animals until we got to the mammals and until we got to us. Can somebody tell me how we are in terms of time? Yes. And we know this because Miller and Urey, they reproduced this experiment in the past, in 1950. They put in the very same elements that scientists believe were floating in the ocean, and they submitted that to electrical charges. And they could see the birth of amino acids in here. So we've proven this in the laboratory. And this is what happened after that. And this might look very complicated, but it's very, very simple to see. This is the entire evolution in one single graph. How do we read this? 4 billion years here on the center when the planet started. And here is today. And also here is today. So we read this in rings. 4 billion years, 3 billion years, 2 billion years, 1 billion years, creating those layers. And through this graph, we see the first type of organisms that were born were bacteria. And then, around 2 billion years, we have plants. And then, around 444 million, we had the first animals, protostomes. And then it grew into echinoderms. This is when the Cambrian explosion happened. The Cambrian explosion is a very, very small period of time where lots and lots and lots of different species were created. And then we kept evolving until us. And here is man. After the ocean rusts, when the earth was so saturated of oxygen that the ocean started to rust, and then bacteria helped to clean the ocean, and then we have the global ice ages, and then we had the Cambrian explosion, and then we had several different mass extinctions. We know one very well, the last one, 288 million years ago, caused by an asteroid that hit the planet and killed all the dinosaurs. But that was not the only mass extinction. Life was extincted and reborn here several times. This is a laboratory where God, Jesus, the spirits are testing DNA material and the behavior of this DNA material in all the environment that's forming around it. And how can we organize all of this? Thanks to Charles Darwin, thanks to the beagle, the sheep that he was invited to travel on, and thanks to Galapagos Island. And this all happened in December of 1831. Charles Darwin was a biologist and a scientist and a geologist, and he was invited to join the crew of the Beagle, and they were supposed to take a 2-year trip around the world, and it took much more than that. And they traveled to several different places. They went to Rio, they went to Montevideo, the Falkland, and then they reached Galapagos here. And Galapagos is very interesting. It's in the middle of the ocean, very far away from the continent. So you cannot fly or you cannot swim from the continent to the Galapagos Islands. This is very far away. Several different volcanic islands. The ocean floor is very, very deep. So those volcanoes, they grew up from the bottom of the ocean to the surface. And each one of those islands, they have different ecosystems and they have different animals in there. Because of the currents and the nature of the ocean there, animals could not migrate from one island to the other, so they developed differently. And Charles Darwin was observing birds and turtles and lizards. And he concluded that each one of the islands had different conditions. And because of those conditions, rock, sand, plants, what type of plants, he could observe different animals that were 100% adapted to the conditions of each one of those islands. And that's what clicked the idea of the origin of species and the book that he wrote. But let's stop a little bit and think about this. This is a plant. This is a beautiful flower. I took this picture here in the Northern California, in the mountains. This is highly complex. For you to have an idea, these white dots here are the female portion of the plant, of the plant. These high purple ones are the male portion of the plant. And this tiny little thing here are the pollen. Think about the complexity to create just a flower. Compare a flower to us. A flower is much simple organism than we are. But in a flower itself, it's a huge complexity. How did we get to this complexity, to this organization? And what is the flower made of? Exactly the same elements that we are made of, just reorganized in a different way. But let's talk about our history here and about our many faces. The Earth was formed 4.6 billion years ago. Then life begins approximately 4 billion years ago. The first unicellular life begins approximately 3.8 billion years ago. And animalia, animals, different from plants and fungi and bacteria, they appear on Earth 590 million years ago. And then inside animalia, some very specific kind of animals, chordata, the ones that have the spinal cord, appear. And then tetrapoda, the ones that have arms and legs, appear. And then mammalia, us. And inside mammalia, the primates. And the first Omnidae genus. And then the genus Homo, the Neanderthalensis, and the Homo sapiens. And this is our timeline. And this is a problem, because every time we see this, we think that we jumped from one into the other. But let's clarify some of those myths. In the past 2.5 billion years, several different species of human beings were living together. We lived with each other through thousands and thousands of years. Several of these different species, they live together, and some of them even tried to mate with each other. And some of them were successful, but did not generate a fertile offspring. But some of those, they did generate a fertile offspring. They were compatible in terms of DNA. And that's how the types of human diversity grew even more. And the Homo erectus was the most successful Homo that ever lived in this planet, because he lived for 2 million years. He was very adapted to when he was living. We are here for 40,000 years. They lived for 2 million years. They were much more adapted than we are to the planet. And Homo neanderthalensis was the first one to create instruments. To take rocks and create instruments, spears and knives and things that could make his life easier. And he was also the first type of human being to domesticate fire. And thanks to domesticating fire, they could be protected from other animals, they could heat themselves in the winter, and they could cook food. And cooked food lasts much longer. So now they can travel. So they started traveling and expanded their population through Europe and western parts of Asia. And then came Homo sapiens. And we lived among many of the other Homo species, including Homo neanderthalensis. And we spread it through the footprints of Neanderthalensis and dominated the world. And this is more realistic. This is according to the Smithsonian Institution. And we are here. So we live together with Naledi, we live together with Erectus a little bit, with Neanderthalensis, Luzonensis, All those other types of human beings live together with us. And what happened? Well, this is how humans expanded through the planet. The first ones, the Homo erectus took over Africa and parts of Middle East and Southeast Asia. And then the Homo neanderthalensis started the migrations. And then Homo sapiens took the migrations and covered the entire planet, including Latin America, through the Bering Strait here. There are theories that we used boats or we crossed the ice caps here in the winter. But that's how humans took over the entire planet. And the only species of Homos that did that was the Homo sapiens. Why only Homo sapiens survived? There are two theories here, and most of the scientists, they believe there is a mixture of those two theories that really happened. First one, the miscegenation. There are traces of other types of human beings in our DNA today. So we probably made and created fertile offspring, and we created new different species, and through that we dominated and incorporated other species into ours. The second theory is about the very first genocide in history. It's a theory of replacement. And there are evidences all over the planet that we really killed all the other species. So we could have done some miscegenation, but the fact that we are here today is because we systematically eliminated all of our competitors in the environment. We've done it before. And only sapiens could do that. Neanderthalensis could not do that. And we're going to see this. And this is related to the birth of the free will. So let's take a look at those two types of human beings, because they were the latest ones and the most successful ones. And we built our history upon Neanderthalensis, and then we took over the planet. So they were very peaceful, but they had the ability to build manual instruments. No one before them could do that. And they also domesticated fire, like we said. And they could cook and use fire to protection. And they created primitive technologies, like ceramics, for instance, very basic ceramics. But they were incapable of something very important that only our brain can do, which is abstract thinking. We had better communication skills. We created languages. They had words. They could communicate and name a few things, and they could talk to each other, but they could not talk about ideas because they didn't know how to create abstract thinking. For them, a tree is a tree, and what's behind the tree, who cares? I'll see when I go behind the tree. We imagine what's behind the tree, and then we imagine why the tree is there. They could never do that. So we generated the ability to generate, we created the ability to generate abstract thinking, and we could imagine stories and tell stories to others. And the ability to tell stories led us to create myths and to convince people. If I tell a story, first of all, I have an intention to tell that story. What's behind the story? Why am I telling that story to you? I want something with that story. And through that story, I can congregate people to a common cause. That's why we were the protagonists of the first genocide. We got each other, we got together with our own species, and we convinced ourselves that we had to clean up the planet so we could take over the environment, we could take over everything that was accessible, we could take over all the food, all the animals, all the plants that were available. So we decided to eliminate competition. This is a sign of free will. Free will is born with the ability to create abstract thinking, the ability to understand intention and to make decisions upon the intentions that we have. I might have the intention to help, or I might have the intention to protect myself. In order to protect myself, I may have the intention to kill the others. And I may have the intention to take what's yours because I want it. Only Homo sapiens could do that, and that started 40,000 years ago. It took billions of years for us to be ready to receive a spirit that could exercise free will in our body. So very quickly, our first common ancestor lived around 40 million years ago. The first species of Homo lived around 6 million years ago. And the first bipedal human being lived about 2.5 million years ago. And we start making tools about 2.5 million years ago. And about 800,000 years ago, we controlled fire. And then, between 800,000 and 200,000 years ago, our brain developed like nothing else. It was the fastest speed of our brain development. And then, we started to move out of Africa. And then we developed the capacity to form language and abstract thinking, and we created what today is called the cognitive revolution. Now we think, so now we create a new revolution because we have intention behind our thinking, and we have the free will to decide what we want to do and how we want to do it. And we developed the first cultural system, and we are the protagonists of the first genocide. And humans started to settle down in primitive farms around 12,000 years ago. And this is so important because until 12,000 years ago, we were just collecting. Oh, so there's a fruit here, I'll stop here, and I'll be here for a week or so until the fruit ends. And now I move to another side. Here, we knew enough about the seasons, about the cycle of the planets that we could observe. We could do primitive astronomy here. We could understand the cycle of the moon, and we could see the effect of the cycle of the moon on the planets, growing faster or slower. So we had enough scientific elements in our primitive brain to help us to settle down. I'm not going to run after food anymore. I'm going to grow food by myself. I found some very cool animals here that don't frighten me, but they provide food to me, so I'm going to farm them. So we started to create farms and settle down into farms. But I was planting a few things and creating some types of animals in my farm, and you were doing something else, and you're doing something else, and she was doing something else. And I couldn't survive only what I was creating in my farm, so I needed to go into our farm and say, give me some eggs, I'll give you some wheat. And we could do this, and we could start exchanging things. But there were people that were doing that for us. So instead of having their own farm, they're traveling from farm to farm and exchanging things. So they're making a living for themselves and also making the lives of the farmer better. And those people started to live around the farm. And living around the farm create the first cities. And then the first civilization happened about 5,000 years ago. And like we said before, then Jesus Christ is born 2,000 years ago. And the scientific revolution starts about 500,000 years ago, when we create and organize our scientific method to try to make sense of everything that came before us. And the French Revolution happened 230 years ago. This was the first time where we officially talked about freedom and rights. It took us a long time to start talking about that. And then about 150 years ago, we started the Industrial Revolution. And we started to poison the planet. So what we did in 150 years broke everything that nature and God did for us in billions of years before us, preceding us to this point. But about 71 years ago, we had the first official Declaration of Human Rights. And then about 50 years ago, we put our man on the moon. Some people don't believe on that, but I do. And the internet started 40 years ago.
Some don't believe on that either.
Some don't believe on that either. And then the Berlin Wall came down 28 years ago. Think about the dimension of those events. Think about everything that was done to create a beautiful planet that could support our life here. And what have we done? 40,000 years ago, we killed everybody else. And since then, we are evolving to get to the recognition of our society, of good in our society. take the ability to create wealth, make life better for everybody. Still, we're not applying that, but now at least we know how to do it. And to create the internet, to turn down the Berlin Wall, and the artificial intelligence has just started. So in summary, God is the origin of the universe. God was part of the primordial Big Bang. He was not outside, sticking his finger and saying everything happens. He turned himself into time, space, energy, from matter to elements and to us. That's the story of love. And we are made of the same elements formed after the Big Bang and present all over the universe. And we are meant to be here, and we are the very best version of ourselves up until now. And everything was and is constantly engineered to allow our evolution. We've seen the entire history of the universe here in less than an hour. And God in his infinite mercy and Jesus in his infinite love provide everything that we need to evolve. Everything is being provided to us. From the universe, to the elements that form us, to the planet where we live in, everything. But we are behind the wheel. God put us behind the wheel of our evolution. Thank you.